Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 15B Part 1 assignment. First one we're going to take a look at here is number 1. Suppose x is normally distributed with a mean of 30 and standard deviation of 5. State the value, which is 2 standard deviations above the mean, 1 below, and these other ones here. Part C says draw a curve to illustrate the distribution of x. I'm going to actually start with that because that's going to help us answer A and B, I feel, a lot easier. So let's do this. Part C. We're going to do our curve here. Oops. Let's try this again. So it looks roughly, just kind of sketching this out. So here's our mean. We'll call that. Mean is 30, right? And then the standard deviation is 5. So we go add 5 each one as we're going up, so 35, 40, 45, and then we subtract 5 each time going down 1 standard deviation. Right, so that's going to be 25, 20, and 15. Okay, so now state the value which is 2 standard deviations above the mean. So here's our mean, right, which really we should write as mu, which is really kind of looks like an M anyway, doesn't it? Just a funky looking M. 2 standard deviations above the mean is 40. 1 standard deviation below the mean is 25. So see how it's much nicer and easier once we have a picture. Describe the following values in terms of number of standard deviations above or below the mean. 35. 1 standard deviation above, right? Or we could even say plus 1 standard deviation. I like that a little bit better. 20 is 2 standard deviations below, so minus 2 standard deviations from the mean. Right? So we could even maybe do mean minus 2 standard deviations, mean plus 1 standard deviation, and 45 is the mean plus 1, 2, 3 standard deviations. So the mean plus 3 standard deviations. Okay. Draw a curve to illustrate the distribution of x. We did. D, what proportion of values of x are between 25 and 30? Right. It really depends on the information that you get. I believe I had nice numbers here, like 68% of the data is within 1 standard deviation of the mean. So we could do 68 divided by 2 gives us 34, so 34%. The book comes up with a more defined version, and they're saying that it's like 68.26. So you take that and divide it by 2, and we get 34.13% of the data. But for what we're doing, I'm fine with that. IB testers, that might be a little bit better answer. But anyway, we've got the idea, and that's the important part. Okay, so E, find the probability that a randomly selected member of the population will measure between 35 and 40. Okay, so in the notes that I gave you, we said 95% of the data is between 2 below and 2 above. So if we've got 68 right here, and then we've got 95 right here. If we do 68 minus 95, oh, sorry, the other way around, 95 minus 68, we are going to get 27, right? Take 27 and divide it by 2, and we get 13 and a half. So this is, we figured out earlier, remember this is 34% here, 34% here, 13 and a half here, 13 and a half here. So between 35 and 40 is going to be 13.5%. Again, the book goes a little bit more detailed on that. They go with 13.59%. But again, for what we're doing, that is just fine. Okay. Number 5, the height of female students at a university is normally distributed with a mean of 170 centimeters and standard deviation of 8. Now it's going to have us try to find all these percentages and stuff. First thing I'm going to do is I'm going to draw a picture, because for me, I feel like I can better understand and what's going on if I can just look at my picture here. So right down here, the middle here, our mean is 170, right? And we got 1, 2, 3 standard deviations above, and 1, 2, 3 standard deviations below. As you can tell, my graph is not perfect, but you get the idea. Standard deviation is 8, so I'm going to add 8, 178, and add 8 more, 186, plus 8 more is 194, and then subtract 8, 162, subtract 8 more, 154, and let's see, 46, right? Okay. Now, find the percentage of female students whose height is between, and then all these probabilities. So let's just do this. We know that these two, like between 1 standard deviation below and above, that's roughly 68% of the data. So we take that and divide it by 2, and that's where we get our 34% for each of these. So this is going to be 34. This is going to be 34. Between 2 below and 2 above is 95%. So 95 minus 68 was 27. So if we take half of 27, that's 13.5. So this is going to be, let's even do this in a different color so that we can read it a little bit better, because that looks like 341, which is not what we want. So let's change this to red here. So this is 34% there and there, 13.5 here. 13.5 there, and then up to the next one is what, 99.7. So if we take 99.7 minus 95 gives us 4.7. 4.7 divided by 2 is 2.35, right? So we'll call this here 2.35, and this 2.35. Again, it's going to be a little different than what the book has. They've got a little bit different percentages, but we're going to be right in the right neighborhood. Okay, so with that, now that we have this all drawn out with all our percentages in there, these questions become a lot easier. Find the percentage of female students whose height's between 162 and 170. 162 and 170, guess what? That's 34%, because we already wrote that out right here. Okay. In fact, let's write that in red since we did all the rest of those percentages in red. Between 170 and 186, 170 and 186, that's 2 standard deviations. That's going to be 34 and 13.5. So that's 47.5% roughly. Okay, find the probability that a randomly chosen female student has height less than 154. So that is from here over, right? So this here is 95% of the data. So that leaves 5% of the data for up above and down below. So take that divided by 2, and that's going to give us that that's going to be 2.5% of the data is going to be below 2 standard deviations underneath, okay, or below the mean. Okay, greater than 162, that's going to be from here over. So that's basically, this is 50%, right? 50% over here plus another 34. So we can do that as 50 plus 34 is going to be 84%. Okay. C, from a group of 500 female university students, how many would you expect to be between 178 and 186? 178 and 186. We would expect 13.5% of the 500 students. So if we're going to do that, we would want to get our calculator out here, and we're going to do 13.5 as a decimal is 0.135 times 500, and that'll tell us exactly how many we should expect. So 0.135 times 500 gives us 67.5. So about 67 or 68, somewhere right in there, right? Because it's right in the middle. We don't want to put a half of a person, because that just doesn't make sense. D, estimate the value of K such that 16% of the female students are taller than K centimeters. So 13.5 plus 2.35, and the rest of this here is 0.15. If you add those all together, guess what you get? You get 16%. So that's going to be 178 or above. Okay? Okay. Taking a look here at, number 7. Weights of 545 babies are born at a maternity hospital last year were normally distributed with a mean of 3 kilograms and standard deviation of 200 grams. Estimate the number that weighed here. So, again, you don't have to draw your distribution graph, but I kind of like to, because then I can put up my mean and standard deviation, and I'm going to pretend that this is a nice mirror image, but I can tell that it's not, but it's all good. So 3 kilograms. Now here's the thing. We've got kilograms and grams. So let's do this. Kilograms. Kilo means basically we're going to move it over 3 spots to the right. So 1, 2, 3. So that's really going to be 1, 2, 3 zeros with that. So that's going to be 3,000 grams. Okay, and then the standard deviation is going to be an extra 200, so that's going to be 3,200. This one here is going to be 3,400, 3,600, and then we can subtract 200 as we go down. So that's going to be, what, 2,800 grams. All these are grams. It's just not enough room to write all that in there, is there? So this one here minus 2 more is 2,600 grams, and then one more standard deviation down there is 2,400. 2,400 grams. Okay, so now estimate the number that weighed less than 3.2 kilograms. So that is from here over, right? Knowing that this whole thing is 68, half of 68. It's 34. So this is going to be 34% plus an extra 50% over here. So this is 34 plus 50 is going to give us 84%. Okay, should be less than 3.2 kilograms. And then B, between 2.8 right here and 3.4. So this amount in here. So this right here we know is 68%. Excuse me, 68%. This right here is another 13.5, so that's going to be 68 plus 13.5%. 81.5% is what B is going to be. Okay. All right, last one. The weights of Jason's oranges are normally distributed. 84% of the crop weighs more than 152 grams and 16% weighs more than 200 grams. Find the mean and their standard deviation for the crop. Okay. So let's do this. I'm just draw a little picture, see if this helps us out. 16%, let's see, 16% weighs more than 200 grams. So that's the top 16%, right? So let's just do this. There's our mean. There's 1 standard deviation, 2, 3. Let's see, this is our mean. There's 1, 2, 3 below. So the top 16% is going to be this 13.5 plus 2.35 plus the other 0.15. So that's going to be from here over. Okay, so 16% weighs more than 200 grams. So we know that this number right here has to be 200. I'm going to move this down here a little bit just so we can see everything else a little bit better. Okay. And then 84% of the crop weighs more than 152 grams. So this is 50 plus another 34 right here. This is going to be our 84. So that's going to be 152. Okay. So the mean is obviously going to be halfway between those two. So to find halfway between those two, then we basically just want to find the average. 152 plus 200 divided by 2, right? 352 divided by 2 is going to give us 176. So our mean is going to be 176. So mean 176. And then standard deviation is the difference between 176 and 200, right? So if we do 200 minus 176, that gives us 24. So standard deviation is going to be 24. Okay. What percentage of oranges weigh between 152 and 224? So there's 152. Let's see, standard deviation is 24, so there's 224 right here. So we're looking for this distance between here, this percentage between these two, right? So this here is 68% up to here plus another 13.5. So we would want to do 68 plus 13.5. And that is 81.5% for this one. Okay. Okay. Excuse me. That's all we have for the 15B Part 1 assignment. If you have any further questions on any of this, please feel free to ask. Thanks.